Hi, hello everyone. Welcome to SK Academy of Mathematics. Today we are going to learn how to solve the problem on Simpson's 1/3 rule. This is the one of the method where we are going to integrate. We are going to find the value of the integral function without integrating the term. Okay, that is, we are going to represent the approximate value by using 1/3 rule. How to represent the solution and how to represent the terms of Simpson 1/3 rule, I am going to teach you now. First, let us represent the Simpson's 1/3 rule formula. Solution: Simpson's 1/3 rule is given by integral x naught to x naught plus n into h y dx, which is equal to h divided by 3 into y naught plus yn plus 4 into, we are going to consider the set of atoms, that is y1 plus y3 plus y5 up to etc. up to yn minus 1 plus 2 into, now we are going to represent the even terms y2 y4 plus y6 etc. up to yn minus 2. See, this is the standard representation of the Simpson's 1/3 rule formula. What we are going to do? We are going to represent h by 3, y0 plus yn, 4 into odd terms and 2 into even terms. This is the standard formula. After representation, we are going to define the given integral function, i.e. 4 to 5.2 log x dx. Okay, let us represent where x naught, x, where this also represented as x naught into x naught plus n into h y dx. X naught represent 4 and x naught plus n into h represent 5.2. Next, y represent log x and n. To represent n they have given 7 ordinates, but n should be multiple of 2. So what I am going to do, n equal to ordinates minus 1, n equal to 7 minus 1, n equal to 6. That is, always please be remember, n should be multiple of 2. Done. Now after this representation, now we are going to remember y equal to log x, but while representing log x, either you need to represent with respect to ln x, or log x should be defined with respect to log base e power of x. Either from these two we are supposed to consider the condition. Ln x is equal to log base e of x. Both are same. But while representing the integral function with respect to the logarithmic function, we are supposed to consider either exponential of function or ln function. See, both the condition gives the same values. What the point? Please remember these values. Okay. Now let us consider x naught. X naught gives you 4. N I have considered 6. See, 6 is the multiple of 2. Yes, but 7 is not the multiple of 2. 6h equal to 5.2. 6h equal to 5.2 minus 4. 6h equal to 1.2. h equal to 1.2 divided by 6. h equal to 0.2. Okay, if you don't know, you can use the calculator. Okay, now after this representation of the given terms, these terms carries at least 2 marks. Now let us represent the tabular column x, y. What is y? Y is also known as f of x. At the point, now that is, what is y? Log. Since I am going to consider log, either ln I am going to consider log base x or ln. You can consider anything. Now let us represent the interval. Corresponding to that interval, I need to represent the log, what value of y, that is log base e power of x. Now what we are supposed to consider, we are going to represent the equation. This is the leading interval. See, I need to consider the interval starting from 4 and ending till 5.2. Between, I need to represent the interval so that the common between this interval should be 0.2. But the ordinates should be 7, interval should be 6. How? Now let us see. First consider, take the calculator, press mode setup, press 7, f of x, you get f of x, then press ln of, to press x, closing bracket, you get x, close the bracket, press equals. Start, I have told 4, end 5.2, and step, that is the common interval, what we have got 0.2. You get the values from starting from 4, 4.2, 4.4, 4.5, 4.8, 5. 5.2. The last is 5.2. Okay, done. Now let us see, represent the values. For the values of x, okay, for 4 I have 1.3862. Next, for 4.2 I have 1.435. Next, for 4.4 I have 1.4816. For 4.6 I have 1.526. Next, 4.8 1.5686, and 5 I have 1.6094, and the last 5.2, that is 1.6486. Now this I am going to represent it as y0, y1, y2, y3, y4, y5, and y6. See, I have 6 interval but 7 ordinates. 1, 2, 3, 4, 5, 6, 7 ordinates. Represent the tabular column. So that while simplification, there will be no mistake while considering the terms. Then now after this, let us represent the formula. Okay, that is using Simpson's 1 by third rule. I have, that is integral x naught to x naught plus n into h y dx, which is equal to h divided by 3 into y naught plus yn. What is n? I have 6, y6 plus 4 into, see odd terms, that is y1 plus y3 plus y5. Okay, done. Next, plus 2 into even terms, y2 plus y4, and y6 is not repeated because since we have considered in the first step. See, y0, y1, y2, y3, y4, y5, and y6. All the terms are considered in the given. Then integral 4 to 5.2 log x, log base e power of x, or ln x, which is equal to, what is h? I have 0.2 divided by 3 into, what is y0? See, please be careful while representing the values. Y0 is 1.3862 plus y6 I have 1.6486 plus 4 into y1. What is y1? 1.435. Next, y3 1.526 plus y5 I have 1.6094, close the bracket after y5. Next, plus 2 into y2 I have 1.4816 plus y4 1.5686, close the bracket. Okay, done. Now by using the calculator, let us represent the solution. That is, see, consider the calculator. To clear this, press shift 9, press 3, press equals, press AC. System will be cleared. Now let us represent the solution. Press numerator denominator, 0.2 divided by 3 into open double bracket, since we have double bracket, open double bracket, 1.3862 plus 1.6486, close the bracket, plus 4 into 1.435 plus 1.526 plus 1.6094, close the bracket, plus 2 into 1.4816 plus 1.5686, close the double bracket, press equals, we get 1.8277. We get, that is integral 4 to 5.2 log base e power of x, which is equal to 1.8277. Whether this, whatever we have found the value, integral approximate value of the integral log base e power of x is correct or wrong, how to verify? It is very easy. Verify the integral 4 to 5.2 log base e power of x, which is equal to 1.8. Okay, let us find whether it is correct or wrong. How? Let us see. First consider the calculator, represent the integral function. You get this integral, what MT, that is log, that is ln base x, close the bracket, press lower button, you get lower limit 4, press upper button, you get upper limit 5.2, press equals. It takes little bit time. 1.8278. 1.8278. This is the approximate, and you can conclude it as also exact value of log base e power of x. See, this is the value when we simplified using Simpson's 1 by 3rd rule, but this is the value after integrating the value of the log base e power of x, that is 1.8278, and this is the value, approximate value. This is almost all similar, that is 1.8277 and 1.8278. I hope you have understood each and every step of the solving Simpson's 1 by 3rd rule. For more videos, please do like, share and subscribe. See you in the next video. Thank you.